Hi everyone, welcome back to the Ansible series. In the previous class, we talked about what Ansible is and why it's so useful for automation. Today, we are going a step further to see how Ansible actually connects to systems and what happens behind the scenes. Let's get started with a quick look at why Ansible depends on Python. Ansible itself is written in Python and most of its modules are Python scripts. Whenever you run a playbook, Ansible connects to your system, sends a tiny Python snippet, runs it, and then removes it after execution. You can think of it like Ansible sending a tiny helper script that runs the task, reports back the result, and then quietly cleans itself up. This is why using Python 3 or above is highly recommended. Newer Ansible modules are designed to work with Python 3 features. Things like better error handling, improved performance, and security updates. If you are running on an older Python 2 setup, some modules might fail or behave differently. So, it's always best to use the latest version of Python 3 for a smoother and more reliable experience. And the good news is that almost every Linux machine already has Python built in. Now, let's see how this connection happens between systems. Here's how it all fits together. You have one machine called the control node. This is where Ansible is installed. From there, it connects to one or many managed nodes, which are the machines you want to configure. For Linux machines, Ansible uses SSH. For Windows, it uses WinRM PowerShell remoting. Once Ansible connects, it reads your playbook and makes sure every system matches the state you defined. For example, if one server is missing a package, another has an outdated version, and a third one is already fine, Ansible automatically brings all of them to the same consistent setup. And that's the power of idempotency, one of the most important ideas in Ansible. It simply means no matter how many times you run the same playbook, the end result will always be the same. Let's say your playbook installs Nginx. The first time you run it, Ansible checks, is Nginx already installed? If not, it installs it. But if you run the same playbook again, Ansible checks and says, oh, Nginx is already there and configured correctly. So it does not reinstall or make unnecessary changes. This behavior ensures your systems are consistent, predictable, and safe to reapply, which is especially useful when managing dozens or hundreds of servers. Now, what if your target machines are Windows servers? Let's see how that works. On Windows, Ansible uses WinRM, which stands for Windows Remote Management. Instead of sending Python scripts, it sends PowerShell commands. Windows modules usually start with win underscore. For example, win underscore copy to copy files, win underscore service to start or stop services, win underscore user to create users. So, whether you work with Linux, Windows, or a mix of both, Ansible can handle everything in a consistent way. And if you are using a Windows laptop, there is a handy tool to connect to Linux servers. MobaXterm. If you are on Windows, you might have heard of MobaXterm. It's a popular SSH client that lets you connect to Linux servers or cloud instances easily. It combines a terminal and a file transfer pane in one window. So you can run commands and move files quickly. It's especially helpful if your control node is a Linux VM or an AWS EC2 instance, but you are working from a Windows machine. Now let's take a look at how Ansible works when it's running from the cloud. For example, on an AWS EC2 instance. In most production or real world environments, we don't usually run Ansible from our personal laptop. Instead, we set up a dedicated control node that's simply a Linux based machine, often an EC2 instance in AWS. Think of the control node as your Ansible headquarters. This is where all your playbooks live and where all the automation starts from. The first step is to make sure Python is installed, because Ansible depends on Python to run its internal modules. The good news is almost every Linux AMI on AWS already comes with Python pre-installed. So you usually don't have to do anything special. Once Python is ready, the next step is to install Ansible itself using a package manager. Depending on your system, you can use apt on Ubuntu, yum on Amazon Linux or CentOS, or brew if you are on macOS. And after installation, Ansible is ready to run directly from that EC2 machine. And here is something really nice. You don't need to install Ansible on any of your managed nodes. Those target machines, the ones you are managing, just need SSH access. When you run a playbook, Ansible connects to them over SSH, sends a small Python snippets or commands, executes the tasks, and then cleans up after itself. So all your automation logic, the code, playbooks and configurations stays in one place, the control node. The managed systems remain untouched except for the actions you define. This setup is extremely common in DevOps environments, especially when you are automating multiple servers like web servers, app servers or databases, all hosted on AWS. It's reliable, scalable, and easy to maintain, which is why running Ansible from a cloud control node like an EC2 instance is considered a best practice. Now that we understand where Ansible runs, let's talk about how to actually install it. The installation steps are quite simple and they depend on your operating system. Let's start with Linux, since that's the most common environment for Ansible. You can install Ansible using pip3, which is Python's package manager, and the command looks like this: sudo pip3 install Ansible. This downloads and installs Ansible globally on your system. And alternatively, if you are using a distribution like Ubuntu or Debian, you can also use the built-in package manager. Both work fine. Next, on macOS, installation is even simpler. You can use Homebrew, which is a popular package manager for Mac. The command is brew install Ansible. This will automatically take care of dependencies and install the latest version available for your system. And finally, let's talk about Windows. Ansible does not run natively on Windows because it's designed for Unix-like environments. But you can use WSL, the Windows subsystem for Linux. Once you have WSL installed and open the Ubuntu terminal inside it, you can run the same command as on Linux. Sudo apt install Ansible. This gives you a full Linux environment where Ansible runs just like it would on a regular server. So whether you are on a Linux, Mac OS or Windows, installation is straightforward and you will have Ansible ready in just a few minutes. I will also show you in the documentation where these commands are officially listed under the installation guide section. We will look at where these commands are listed in the official Ansible docs in one of the next sessions. Alright, let's quickly recap what we covered in this class. We started by understanding why Ansible needs Python, since it's built on Python and uses it behind the scenes to execute modules on target systems. Then we looked at how Ansible actually works, the difference between the control node where Ansible is installed and the managed nodes, which are the systems it manages. We also talked about how it connects using SSH for Linux machines and WinRM for Windows, and how Ansible keeps all your systems consistent using something called idempotency. After that, we saw how Ansible runs from the cloud, especially on AWS EC2, where you install Ansible once and manage all your services through SSH. And finally, we went through the installation overview, the basic commands for Linux, Mac OS and Windows using WSL. So by now, you should have a clear picture of how Ansible connects, what Python's role is, and where Ansible fits in a real-world setup. In the next class, we will move from theory to practice. We will open Visual Studio Code, write our very first playbook, and actually run it to see Ansible in action. Thanks for watching. See you next time. Remember, Automation made simple with Ansible.